Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at using objects of your own classes as the keys in maps. And this is going to turn out to be surprisingly enlightening, and we're going to get our first look at operator overloading. So I've got this program from the last tutorial. We've got a person class with a couple of fields. We've got a default constructor, a copy constructor, and a constructor that accepts the parameters as a convenience. I've also got a print method that displays what's in this object, and at the moment we're creating a map that uses objects of that class as the values in the map. Let's change this so it tries to use the object as the key in the map. So I'll change the key to person and the value to int, and now we can add people to the map. We can try to use the objects as the keys in the map. So let's make them look like this. And I'm just going to copy this line and get rid of these, paste it in twice again and change it. So let's have Sue, Raj, let's make them 30, 20, and we'll set this to 30, 20 as well, just so that we can more easily see what's going on. But of course the value could be anything you like. We'll get rid of these inserts with make per here, because we don't need those for this tutorial. And this iterator needs to change because it's now iterating over a map of person with int as the value. And we can call print on the key in the map here. And let's also output the age there as well, the value. And I'm going to change the endler in this print method just to a flush. It's not really good practice to put an endler in a method that prints things out anyway, because you should just leave that up to the user, the caller of the method. Now if we try to build this, this is kind of a naive implementation that doesn't actually work. One of the first errors that we're probably going to get is that it's going to say this print is not marked const. It says that in a slightly cryptic way, possibly, but yeah, slightly cryptic. But that's the gist of it. The thing is that the keys in the map, as retrieved by this first using the iterator, they're const. The map doesn't want you going in there and altering the keys, because that should change the way they sort in the map. So the keys being as important as they are, the iterator returns them as const values. And print isn't marked as const, so this method could change the key, and that's why we're not allowed to call it here. So to make it work, we have to explicitly mark it as const. That would mean that print could not change the instance variables. You'll get a compile error if you try to do that in print. And then we can call it here. So let's now build this, and we're still going to get an error here. So we get an error. By the way, it's important to start looking at error traces. Start looking from the top and then work down. And if I get an error that I don't understand, I just paste that into Google, remove any specific bits like line numbers or names of objects I've defined myself, classes I've defined myself, and possibly add in more information, for example STL map, because you can often find other people who've got those error messages before, and people can explain what it was caused by in a way that's a lot easier to understand sometimes than the error message that the compiler gives you. That's just a side note. Now the problem is here, which you couldn't immediately guess by looking at this error message, but you probably could find it by Googling the error message, is that C++ doesn't know how to compare different objects of the person class, and it has to do that because it has to sort the keys of the map in the right order. And the way it does the comparison ultimately is by using the less than operator. Now imagine we've got two objects here. Let's say, for example, string, let's call it test1 equals Mike, and string test2 equals Bob. Imagine we compare them with the less than operator. So we say bool test equals test1 less than test2. So This would return true if test1 is less than true and store it in this Boolean variable. If test1 is greater than test2, it's going to return false. If you look at this and you think about it, this less than operator is behaving very much like a method, like a call to a method that belongs to test1 and passes it test2. So in fact we can think of the less than operator exactly like that, as being a sort of method of this in this case it would be the string class, and we pass another string to it and it returns true if the string that we're calling the method on, which is actually the less than operator, is less than the second, false otherwise. So that means we can actually implement our own version of this operator in our own class, which is what we need to do in order to be able to store, in order to be able to use our own objects as keys in the map. And what that looks like is the following, and we're going to look at this in more detail in a section of the course in the future on operator overloading, but we'll get started here with a first taste, since we need it at this point. So the less than operator is going to return bool, as we've seen, and we use the keyword operator when we're overloading an operator, and then we type the operator that we want to overload. You can put a space in there, but it's common not to, so let's just write it like this. Then we need to specify the parameters that this operator accepts, and as we've seen, this operator is going to look at the object it's defined in, and we need to pass it the other object to compare this one with. So we've got to pass it one other person object, and that has to be marked a const reference. So let's say const person reference other. The reference for efficiency, we don't want to create a copy of the person when we pass it in here, and const because we don't want less than to change the other object. That would be crazy if you had a less than operator that actually changed the things that it operated on. And it's also very important that we mark the whole method as const, because this operator shouldn't change this object either, shouldn't change either of them, neither this one, so this is const, neither this object, so the whole method is const as well. We have to put both of those consts in to get this to work in our map. We have to correctly overload it with the right syntax. So let's put the brackets in there, and we call it operator overloading. Overloading in the sense that we're giving it a new overloaded meaning in addition to whatever meanings this operator had previously. Although it didn't have any meanings in the context of this particular class. There's no implicit less than operator, but of course it has meanings in other contexts in C++. So now how are we going to do that? Well, let's say that we consider one object of this class to be less than the other. If the name is alphabetically less than the name of the other object that we're comparing it to, then we can use the string less than operator, and we can simply return name is less than other.name, because that's going to return true if this name here is less than the other object's name and false otherwise. So now that we've done that, let's see if this works. So if we run this, we can hopefully output the values in our map. Let's get rid of this copy constructor running thing. So that's a bit annoying now, we don't need it anymore. And also I just want to put a cout endler in this loop to make this a little bit clearer. So let's run this again. And we can see that now it works. We've successfully used objects of our class as keys in the map. Now it's interesting to look at what happens if you try to add a new object with the same key. Let's do that. Let's add Mike. Let's maybe give him a different value, but we'll have the same object. Now if we run this, what happens is we've updated the value in the map, because C++ has used, that the map has used this less than operator to compare objects. It said, okay, this is the same key as this by definition of this operator. By the way, this operator defines that. Therefore, I will change the value in that map from 40 to 30. So we can maybe see that a bit more clearly if I change it to something it's easier to see, although 123 is extremely old. But there we can see we've got 123 coming out for the value there, which I displayed here. Let's change the age in the person object itself, which remember is the key. So the person object, which is the key, stores both the name and the age itself. Let's change this to 321. No, maybe something like 444. There we do. There we go. Just so it's completely clear. Then we find that the value in the key has not been updated, and the reason for that is when you do this, when you try to insert a value into a map and the key is the same as an existing key, it doesn't change the original key. So the original key is, you can't insert another key again into the map that has the same value as an existing one, but it does update the value. So what this is going to do is it's going to say, okay, this key is the same as this key, therefore I'll update the value of this existing key to have this new value, but the key itself is not going to be changed. It's not going to overwrite the existing key. Now this situation is perhaps a bit peculiar in as much as we've got two different objects here with different ages, but they're considered the same. And if you want the age to be taken into account as well, you can very easily do that in your less than operator. We can say if name is equal to other.name, then go ahead and compare the ages. So return age is less than other.age using the integer less than operator. Else, although the else is technically redundant here, but we'll put it in to make it look a bit more elegant, because once you've returned, you're not going to do anything else anyway. And now if we do this, now this is going to mean that these two objects are different keys, and we can insert this second one into the map because it has a different age. So if we run this now, we see that we've now got two mics. They're different because the ages are different, and this defines the fact that they are different by comparing the age as well as the name. Okay, so that's it for this tutorial. Well worth practicing this, because apart from anything else, you'll get a first go at operator overloading. So again, it's worth trying to type this out. Look at the error messages you get if you don't add the extra bits that you need, like a const print statement, for example, if you've got a print statement. And if you get the operator, if you don't have the operator in there, look at the error messages, then define them and try to do it from memory. But you're probably going to end up having to refer back to this. But it's worth a go just to see what happens if you try to muddle through, see what error messages come up, and try to get that working, and define your own less than operator in an object you defined yourself. You learn really a huge amount by doing that, even though the first time you do this, at least in my experience, it doesn't stick in your mind because operator overloading looks a bit complicated. But we are going to come back. We're going to have a whole section on operator overloading later on in this course. Okay, so that's it for this tutorial. Until next time, happy coding.